Hi, my name's Darren Wood, and I'm a systems engineer here at Objectivity. Today I'm going to take a look at a demonstration that we put together which addresses one of the really common use cases we see amongst our customers, and that is around link hunting, which is a specialization of link analysis. So before we take a look at the actual demo, we're going to talk a little bit about what link hunting actually is. This is basically a subset of the area known as link analysis, and it deals with the ability to take any two entities within a data set and find the relationships between them and then make some meaningful conclusions about what that information actually means. So this is a pretty straightforward problem if we're really just dealing with 1 degree of separation. So that's taking any entity in the database and finding out who that entity, say a person, is connected to by people that they've met with, or perhaps people that they've called, or people they've paid money to. But the real value comes when you can do this via multiple degrees of separation. And that's what a lot of Objectivity customers come to us wanting to do, because in existing database systems that they have in place, it's really a very difficult problem to go out to, say, 4, 5, or 6 degrees of separation and find the relationships between any two entities, even if they are via other entities in the database. A little example that we have here at the bottom of the slide shows a very basic scenario where Bob calls John, John has a meeting with Sam, and Sam pays Kay. Now, in a typical database, these pieces of information are stored discretely, so they're stored all over the database, and they are generally the result of disconnected data ingest streams, so when that data was ingested, it wasn't related in any way. So the demo application I'm going to show you revolves around this same concept. We've taken an Objectivity database and we've ingested 100 million phone calls into it. And these phone calls are between random targets, so random phone numbers. So the demo application actually allows us to take any two of those phone numbers in the database and find all of the relationships that exist between them up to 5 degrees of separation. So let's just switch views now and have a look at the application itself. You can see in these boxes down the bottom of the main dialog that I have a couple of numbers pre-selected, and we're just going to start a hunt with these numbers and show you what the results look like. What the application is actually doing now is it's taking the start number that I've provided, and it's following all of the paths and relationships that have been built up in this database by ingesting 100 million phone calls, and it's finding all of the paths in the database that lead to the end number that I've provided. Now, of course, there's a tremendous amount of data in this database, and there are millions of possible paths between these 2 points, but in the short amount of time the demo has been running, it's already been able to find those matching paths and display them on this graph. So this graph shows us one view of our results, but we're able to actually click on this map here and show a geographical representation of the results as well. So let's say that I work for an intelligence organization and Sherry here is of some interest to me. So I can zoom in on Sherry a little bit and take a look at details and where she lives. And what I'm going to do now is I'm just going to go and say, well, we're aware of Sherry, and we're aware of a partial phone number for somebody we think that she's associated with, but we've never actually been able to link the two together. So I'm going to type the phone number here into the search box, and I'm going to search for that result, and I'm going to send the endpoint of my search for this new suspect, Lisa. And let's start the hunt again. So again, Objectivity here is allowing this application to go out and search through millions of relationships, and it's doing this at around 200,000 relationships a second. And this is all running right here on my laptop, so we're using very modest hardware here to perform this. This is an amazing amount of data and analysis being done, all on a regular Core 2 Duo laptop. In addition to this, because of Objectivity's unique distributed architecture, if I was to add another laptop on the desk beside the one that I'm using now, and add that into this system, we would get pretty much twice the performance and we get the results back in half the time. This is due to the fact that Objectivity does not make use of a single centralized server, and in fact it distributes the processing load of the database across whatever hardware is available to it in the system. So the results are complete, and we can see here all of the relationships between our two suspects. And although they never communicated directly to each other, investigators now have the opportunity to go and look at the people who have perhaps communicated information between them. We're going to switch back out of the application and take a look at what makes Objectivity perform so well. There are actually a number of things that give Objectivity this advantage. The first I touched on a little bit before, it's the unique distributed architecture of Objectivity. So we're able to distribute the processing power of the database across whatever server infrastructure you have in place. In addition to this, Objectivity stores all of its data natively. So however the data is represented in memory in your application, that's exactly how Objectivity stores it. So unlike traditional relational database systems, there is no object relational mapping code that needs to get run before the information arrives in your application. For this particular demonstration, probably the most important difference is that Objectivity stores relationships right with the object that owns them. So therefore we treat relationships and associations as first-class citizens. And what that allows Objectivity to do is traverse those relationships in memory and orders of magnitude faster than going back to a relational database to do a query. I just want to take a moment to talk about some of the other applications that we see our customers using this type of technology in. The obvious one is the one covered in the demo, and that is of crime and homeland security type scenarios. And that's where you're trying to discover known associates of criminals, or looking for funding or chains of communication between people of interest. Other interesting applications include fraud detection, so watching the movement of money and financial transactions, and also online advertising and analysing the browsing behaviour of your targets. Finally, social networks allow people today to browse people that they are actually related to directly, but up until now they don't allow you to find out who you're related to by several degrees of separation, and this type of technology would enable that as well. Thanks for joining us for the link hunting demo. If you'd like more information about the demo itself, feel free to contact us directly or visit us at www.objectivity.com.